Welcome to this tutorial on Kubernetes on Amazon Web Services, focusing on elastic Kubernetes service setup and deployment. In this video, you'll learn how to deploy and manage production-ready Kubernetes clusters on AWS using EKS. This is part of our Kubernetes Cloud series, designed to help you master container orchestration in the cloud. Amazon Elastic Kubernetes Service, or EKS, is a fully managed Kubernetes control plane service offered by AWS. Instead of manually setting up and maintaining Kubernetes master nodes, AWS handles all the heavy lifting for you. EKS automatically manages the master nodes across multiple availability zones, providing built-in high availability and automatic scaling. It integrates natively with other AWS services like identity and access management, elastic load balancing, and virtual private cloud. This means you can focus on deploying your applications rather than managing infrastructure, giving you production-ready clusters in minutes. The EKS architecture consists of 4 key components. First, the control plane, which includes the Kubernetes master nodes managed entirely by AWS. These masters are automatically distributed across multiple availability zones for high availability and are auto-scaled based on demand. Second, the data plane, which consists of your worker nodes. These can be EC2 instances that you manage or serverless Fargate pods. Third, VPC networking, which handles the networking layer including subnets, security groups, and load balancers that connect your cluster components. Finally, identity and access management integration, which provides role-based access control using AWS IAM for authentication, allowing seamless security management across your cluster. Before setting up your EKS cluster, you'll need a few prerequisites in place. First, an AWS account with appropriate permissions to create EKS clusters, EC2 instances, and VPC resources. Second, the AWS command line interface, or CLI, installed and configured with your AWS credentials. Third, kubectl, which is the Kubernetes command line tool used to interact with your cluster and manage deployments. And fourth, eksctl, which is a recommended utility that greatly simplifies the process of creating and managing EKS clusters. We'll be using eksctl in this tutorial because it automates many complex steps that would otherwise require multiple manual commands. Let's install eksctl, the command line utility that makes EKS management simple. On Linux or macOS, you can download the latest release using curl. The command downloads the eksctl binary for your operating system, extracts it to the temp directory, and then moves it to user local bin so it's available in your path. After installation, verify that eksctl is working correctly by running eksctl version. This should display the installed version number. On Windows, you can install eksctl using Chocolatey or download the binary directly from the GitHub releases page. Once installed, you're ready to create your first EKS cluster. Creating an EKS cluster with eksctl is remarkably simple. With just one command, you can provision a fully functional Kubernetes cluster. The eksctl create cluster command accepts several parameters. The name flag specifies your cluster name. Here we're using my -x- cluster. The region flag determines which AWS region to deploy in, such as us -west-2. The node group -name flag names your worker node group, here called standard -workers. The node -type flag specifies the EC2 instance type for your worker nodes, like T3.medium. And the nodes flag sets how many worker nodes to create, in this case 3 nodes. This single command will provision the control plane, create worker nodes, configure networking, and set up all necessary IAM roles. The process typically takes 15 to 20 minutes to complete. For more advanced configurations, you can use a YAML configuration file instead of command line flags. This cluster.yaml file provides a declarative way to define your EKS cluster. The file starts with the API version, which is eksctl.io/v1alpha5, and the kind field set to cluster config. In the metadata section, you specify the cluster name and AWS region. The node groups section allows you to define multiple node groups with different configurations. Each node group has a name, an instance type like T3.medium, and a desired capacity specifying how many nodes you want. This approach is especially useful for complex setups with multiple node groups, custom networking, or specific IAM policies. You can create the cluster using this file by running eksctl create cluster-f cluster.yaml. After your EKS cluster is created, you need to configure kubectl to communicate with it. The AWS EKS update-kubeconfig command automatically updates your local kubeconfig file with the cluster connection details. You specify the region where your cluster is located and the cluster name. This command retrieves the cluster endpoint and authentication information, then adds it to your kubeconfig file, typically located at .kube/config in your home directory. Once configured, verify the connection by running kubectl get nodes. This command should display all the worker nodes in your cluster, along with their status, roles, and Kubernetes version. If you see your nodes listed with a ready status, your kubectl is successfully connected to the EKS cluster. Now let's deploy a sample application to verify everything is working correctly. We'll deploy Nginx, a popular web server. First, create a deployment using kubectl create deployment Nginx with the image flag set to Nginx. This tells Kubernetes to create a deployment named Nginx using the official Nginx container image from Docker Hub. Next, expose the deployment to make it accessible from outside the cluster. Run kubectl expose deployment Nginx with type set to load balancer and port set to 80. This creates a service that provisions an AWS Elastic Load Balancer automatically. Finally, check the service status by running kubectl get services. After a minute or two, you'll see an external IP address or hostname assigned by AWS. You can access your Nginx application using this address in a web browser. Let's recap what we've covered. First, Amazon EKS provides a fully managed Kubernetes control plane, eliminating the operational overhead of managing master nodes yourself. AWS handles availability, scaling, and updates automatically. Second, eksctl dramatically simplifies cluster creation and management. What would normally require dozens of manual steps across multiple AWS services can be done with a single command. Third, EKS offers native integration with AWS services like identity and access management, elastic load balancing, and CloudWatch, making it easy to build secure, scalable applications. And finally, you can have production-ready infrastructure running in just minutes, allowing you to focus on developing and deploying your applications rather than managing Kubernetes infrastructure. You now have the foundation to start deploying containerized applications on Amazon EKS.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.